All right, my friends, and what we're going to do today is put everything together that we've talked about in the last 3 lessons. All right, so this is going to involve our simplifying rational expression, finding those vertical asymptotes, those holes, horizontal asymptotes, and intercepts. All right, so we're going to put all that information together, and we're going to graph these rational functions that are not in HK form. All right, so today there's no opener. All right, we're just going to dig right into it, all right, and get right into the process. So putting it all together. All right, so now let's look at our steps that we're going to use, all right, when we graph our rational functions. All right, we're going to identify our horizontal asymptote. And remember, we have 3 cases for that. Then we're going to factor the numerator and the denominator completely. All right, once we've done that, we're going to identify our holes, right, and simplify our expression. We're going to identify our vertical asymptotes. And by doing that, that's going to set our domain, right? Then we're going to find our y-intercepts and x-intercepts. And then the little piece that we're going to add today is that now we're going to look at, once we have all that information on the graph, do we need a few more points, all right, to fill out our graph, all right, and sketch our curves. All right, so let's go right to problem 1 here. All right, so we want to graph f of x equals negative x squared minus 7x minus 12 over x squared plus 5x plus 4. All right, so now what we want to do, step 1. All right, identify that horizontal asymptote. Now remember, when we do this, we're going to compare the degree of the numerator to the degree of the denominator. All right, so in this case, we have a second degree over a second degree, so those are the same. And when the degrees of the numerator and the denominator are the same, we will have a horizontal asymptote, and it will be equal to the ratio of those leading coefficients. So in this case, we have negative 1 to 1, so our horizontal asymptote is going to be y equals negative 1. All right, so what I'm going to do right now is I'm going to go ahead and sketch that, all right, on our graph here. So y equals negative 1. All right, so there's the first step in our process. Okay, so now what we want to do is factor completely. Now, once again, all right, I'm just going to do this on a separate sheet of paper here, all right, just so have a little bit more room, make things a little bit cleaner for you. Now, when we look at the numerator here, all right, once again, we typically want that a value to be negative, so, or excuse me, to be positive instead of negative. So if it is negative, we want to factor that out. So I'm going to factor out a negative 1 here, and that means this is x squared plus 7x plus 12. All right, and then once again, I'm going to jump into our area model real quick. All right, a term in the upper left hand, all right, c term in the lower right hand. We're going to do a times c, so that's 1 times 12, which is positive 12. All right, and then we have to find those factors of 12 that add to be 7x. All right, so when I look at this, I know that 4 times 3 is positive 12, and then that means that 4x plus 3x is 7x. All right, I'm going to drop that 4x in here, 3x in here, and then now once again we're doing those GCFs, right? So GCF in our first column is x, our GCF in our second column is positive 4. Our GCF in our first row is x, our GCF in our second row is positive 3. All right, so we can see that our 2 factors of the numerator, and I'll just bring that right here, all right, would be x plus 3 times x plus 4. So there's our numerator. All right, so now let's look at our denominator, x squared plus 5x plus 4. So now in this case, we don't have a GCF to factor out. We don't have a negative a term, so we can jump right into our area model. All right, once again, a term, c term. We're going to do a times c, so 1 times 4 is 4. And we have to add to get that middle term of 5x. All right, so now when I look at this, all right, it's going to be 1 times 4 is 4. And then 1x plus 4x is 5x. Now, once again, if you want to factor on your own, and I'm going a little too fast for you, you can always pause the video, do the factoring on your own, then restart it to see if it matches. Once again, your method of factoring, as long as it's good and solid, you're getting the same answers that I am, rock solid. All right, so keep doing that. All right, so I'm going to drop the 1x in here. I'm going to drop the 4x in here. All right, so we look at that first column again. Our GCF is x. Look at that second column. Now, notice, all right, the only thing we can factor out of our second column is 1. All right, first row, our GCF is an x. Second row, our GCF is a positive 4. See if I can write that. There we go. All right, so now there's our 2 factors, x plus 1 and x plus 4. So x plus 1 and x plus 4. All right, so let me just set that to the side for now. All right, so now here's what we know. All right, we know we have two domain issues, right? So we know x cannot be -1 because that makes this factor 0. We know x cannot be -4 because that makes this factor 0. All right, so now we're looking for common factors, all right? So common factors in the numerator and denominators, all right, are what generate our wholes. So notice that would be the x plus 4, all right? So that means when I simplify here, I'm left with x plus 3 over x plus 1. So what I know is I'm going to have a whole, all right, at -4. Now remember, to find the y-coordinate of that whole, I'm going to take -4 and I'm going to plug it into this simplified version. Because it looks like I can use it, but we know we have to throw it out. So if I do that, I get -4 plus 3 over -4 plus 1. All right, and so -4 plus 3 is -1. -4 plus 1 is -3. So that is 1/3. All right. Okay, so now, oh, and I almost made a really big mistake here. All right, and this is why we need to do this, and I need to come back to the film here, or to work here. I forgot my negative here. So once again, we have to take that negative in here, and that's why it's really big, because I need to put that -1 here, which means I have that -1 here, all right, which means if I add that on here, that's going to change my sign here. All right, so that's going to be -1 times -1, which is going to be a positive. So then my end result will be a -1/3. So once again, you can see I almost made that really big mistake, which is a very common mistake that once you factor out that constant GCF, not to carry it with your problem. So don't be like me. Be better than me. All right, don't make that mistake. So then we get, all right, our whole is -4, -1/3. Okay, so now what does that mean? We go to -4, -1/3, right? So I'm just going to put an open circle, and once again, we know we're approximating here. All right, kind of hard to do -1/3. All right, so now we go to our vertical asymptotes, right? Okay, our vertical asymptotes are where our simplified version is still equal to 0, and so that would be at x equals -1. So we have one vertical asymptote. All right, so I'm going to draw that in like so. There we go. All right, so now we want to find our y-intercepts. So the way we find our y-intercept is we know for every y-intercept x is 0. So I want to plug 0 in for x right here. So I'm going to have -1 times 0 plus 3 over 0 plus 1. All right, and so now when I see this, all right, I'm going to get 3 times -1, which is -3, and then I get 1 here. So my y-intercept is going to be 0, -3, which would be right here. All right. Okay, now I want to find my x-intercepts. Now the way we find our x-intercepts, all right, is we take the numerator of our rational function and we set it equal to 0 and solve. So I'm going to take my numerator right here. So that would be -1 times x plus 3 is equal to 0. All right, notice I can divide by that -1 right away, and that means that x plus 3 would equal to 0, which means x would equal to -3. So my x-intercept is -3, 0. All right, so that would be right here. All right, so now when I look at my curve, all right, so now question 7, do we need more points? And I feel like with what we have here, we don't really need more points. I feel that we can, all right, graph this, because here's what we know. We know it's going to hit the x-intercept. We know it's going to hit that hole, and we know it has to come out and get really close to the horizontal asymptote in that direction. All right, we know it's going to go up and through, and then it's going to come up this vertical asymptote here. All right. Now, if I look at what I have down here, all right, when I look at what I have down here, here's what I know. All right, it's going to have to follow this vertical asymptote going to the left. All right. Now, it's going to come up and through, and we know it's got to get to this horizontal asymptote here. Now, once again, notice we don't have any x-intercepts out here to the right. So we don't have to worry about this like coming up and coming back down. So it's going to just come up and then follow that horizontal asymptote like so. Now, if you were unsure about that, all right, you could just take x values and plug them into your simplified version here. So for example, I could take 1 and plug it in. All right, so we could say, okay, I'm going to plug in 1 and see what happens. So I'd have -1 times 1 plus 3 over 1 plus 1. All right, so that'd be -4 in the numerator divided by 2, which is -2. And you can see I almost hit that point right there. So there's -1, -2, right? So you could pick points and then plug those in, all right, and just generate more points on your curve if you feel like between all this other information there wasn't enough information for you to sketch, all right, your graph. Okay, so same thing, I could plug in -2 here to make sure that it's going up, all right. Okay, so remember, you can always add more points if you're unsure, okay. All right, let's do one more together. All right, so let's flip over and look at number 2 here. Okay, so now when we look at number 2, all right, the first thing we want to do is find that horizontal asymptote. So I got to look at the degree of the numerator to the degree of the denominator. All right, and so notice in this case, we're in that first case that we talked about in our last lesson. The degree of the numerator is greater than the degree of the denominator, which means we will not have a horizontal asymptote. So no horizontal asymptote this time. All right, so it does not exist. All right, NA if you want to put that. All right, so now no horizontal asymptote. So now we got to go to step 2, which is factor everything completely. So now once again, just to save a little bit of room here, I'm going to write a little bit bigger than that space. All right, I've written out my numerator and my denominator. All right, so now first thing, when I look at the numerator, it does have a GCF, and that GCF is x. So I'm going to take that x out. All right, and I get x squared minus 2x minus 8. All right, and now that I'm in my quadratic, now I can jump into my area model. All right, A term, C term. All right, so I'm going to do A times C, so 1 times -8 is -8. And then I have to add to get our B term, which is -2x. Now, once again, we know this is a negative number, so we know we have one factor has to be positive, one factor has to be negative, which means we're adding positive and negative terms, and we get a negative result. So it means our larger factor has to be negative when we think about our rules, all right, for adding and subtracting positive and negative numbers. So that makes me feel like it's -4 times 2, which is -8, and then -4x plus 2x, which is -2x. All right, so let's drop that -4x into this slot. Let's drop that positive 2x into that slot. All right, so now first column, our GCF is a positive x. Second column, our GCF is a -4. All right, first row, our GCF is x. Second row, our GCF is a positive 2. So our numerator factors into x times x plus 2 times x minus 4. Now, I'm going to be good this time. I'm going to make sure I take out that GCF and keep that in our problem here. So I'm not going to make the same mistake I made just a few minutes ago. Make sure I take all of our pieces there. All right, and so there's our numerator. All right, so now let's look at our denominator, right? -2x squared plus 4x plus 6. Now, you're going to notice once again here that a term is negative, and we have a GCF of 2. So I'm going to factor out that -2 out of that quadratic. So I'm going to take that -2 out front. That's going to make this x squared, and then minus 2x, and then minus 3. All right, so once again, that's going to help us because now we don't have nearly as many combinations to look at. So let's drop into that area model. All right. And like I said, I think it's good to have some paper, extra paper, because some of the space we give you may not be enough. All right, and we don't want you to make those tiny mistakes. So grab an extra sheet of paper, do some work on the side. All right, awesome. It makes you look a lot better in the end when you can kind of spread everything out and not have to scrunch it in. All right, so there's my A and my C term. So I'm going to do A times C. So 1 times -3 is -3. And then I have to add to get my middle term here, which is -2x. Now, once again, same situation. We have a negative number here. So I'm going to have a positive number and a negative number. I'm adding, and my result is a negative number, so my larger factor has to be negative. So I'm going to go with -3 times 1 is -3. And then that means -3x plus 1x is -2x. All right, so drop the -3x in here. Drop that positive 1x in here. All right, once again, looking at that GCF. In that first column, it's just an x this time. That GCF in our second column, notice is going to be -3. Both terms are negative, so we want to take that negative out. All right, we look at that first row, the GCF is just an x. And we look at that second row, all right, notice there's nothing in common except for 1. So remember, when you look at this, if there's nothing in common, we just factor out a 1. All right, now once again, I'm going to be good about keeping that constant GCF out front, and that factors into x plus 1 and x minus 3, like so. So let me carry that over. So negative 2 and x plus 1 and x minus 3 like that. All right. Okay, so there we go. There's our factored numerator denominator. All right, so right now, here's what we know. Okay, we know we have two issues, right? For my first factor right here, we know x can't be negative 1. For my second factor here in the denominator, we know x can't be 3. So those are either going to be vertical asymptotes or holes. So notice this time, all right, we do not have any common factors in the numerator or the denominator, all right, to simplify. So once we factored, this is it. This is our form that we're going to work with. All right, so identify any holes and simplify. Well, we can't simplify. Therefore, there are no holes, right? There are no common factors, so we don't have any holes. So notice in this particular problem, we don't have a horizontal asymptote. We don't have a hole, okay? All right, so that's why you have to go through the process. Okay, now, vertical asymptotes. Well, what that means is both of our values up here are going to be vertical asymptotes. So we're going to have multiple vertical asymptotes. We're going to have one at x equals negative 1, and we're going to have our second at x equals 3. So let me draw those in real quick. X equals negative 1 here, like so. All right, and then x equals 3 would be right here. Make sure I'm in the right spot. All right, so this is going to be where it's going to look a little different. So all the rational functions that we've really looked at so far have had 2 pieces. All right, now we're going to get to, it's going to have 3 pieces. We're going to have a piece out here to the left. We're going to have a piece in between the 2 vertical asymptotes, and then we're going to have a third piece of our graph out here to the right. All right, so we want to find our y-intercepts. All right, so to find our y-intercepts, we put 0 in, all right, wherever there's an x. All right, and I should write f of x equals up here. All right, so then if I put in 0 for x, I'm going to have 0 times 0 plus 2 times 0 minus 4 over negative 2 times 0 plus 1 times 0 minus 3. All right, so it looks like the entire numerator then, it doesn't matter what these are going to be because that's going to be a 0. All right, and then we're going to get negative 2 times 1 times negative 3, which is a positive 6, which means that our y-intercept is going to be 0, which means it's 0, 0, which also happens to be an x-intercept as well. So we know our graph goes through the origin here. All right, so now, find x-intercepts. So when we find our x-intercepts, we take the numerator, and we set it equal to 0. So we take x times x plus 2 times x minus 4 and set that equal to 0. And now, this is a little bit simpler because if we have 3 things that multiply to 0, we can use the 0 property here of multiplication. So that means, all right, that means x could be 0. That means x plus 2 could be 0. That means x minus 4 could be 0. All right, so x equals 0. All right, that's the same one right there, right? 0, 0. All right, so when we look at our second factor here, all right, negative 2 would make that 0. So then our second intercept is negative 2, 0. And then we look at this, all right, x equals 4. So we end up with, all right, 3 x-intercepts, all right? So I'm going to plot negative 2, 0 here, and then I'm going to plot 4, 0, which is out here. All right, so now in this case, I don't really feel like we have enough information, all right, to, all right, sketch this. So I want to add more points, all right, to our graph. So I'm going to take some values here. I'm just going to make a table of values here. And we're just going to take some values in the left-hand zone over here, all right, and maybe a couple in the middle and then another couple over here on the right, and just plug them in and see what we get. All right, and I'm going to take negative 3 and negative 4. I'm going to start over here. I'm going to see what happens to this graph when we plug those in. All right, so I'm going to take negative 4 and plug it in. I'm going to take negative 3 and plug it in. All right, then I'm going to take 1 and 2 right here and plug it in and create points there. And then I'm going to take 5 and 6 here and plug those in. All right, and so I'm going to just take those points, all right, take them and plug them into our equation right here, just like what we did, all right, to get my y values. All right, so now this is where just take it and plug it into your calculator. It works really well, all right. Just to save a little time here, if you want to do that on your calculator, I would advise pausing the video, all right, use your calculator, plug in negative 4, and then see if you get the same value I have already generated on my calculator, okay? All right, and then if you don't, then talk to us because we want to make sure you know how to use your calculator. All right, so when you plug in -4, all right, and when I plug in -4, I get 0.87. All right, so -4, 0.87 is almost 1. So right there, I'm sorry, 1.5. I made a mistake, 1.5. Looked at the wrong value. So 1.5 is right there. When I plugged in -3, I get 0.87, which is almost 1 right here. Okay. So now when I look at what I have up here, when I plug this, let me bring it down so you guys can see it. So 0.87, all right, 1.5. It looks like I'm going to come up and go through this, and we noticed we said there's no horizontal asymptote, right? So it's going to kind of keep going in that direction. It goes through this, and now it has to approach and come right down that asymptote like that. So we kind of get a bend here, just like so. All right, so now let's look at what happens when I plug in 1 and 2. All right, so when I plug in 1, I get -1.12. All right, so -1.12 is like that. All right, when I plugged in 2, I get -2.67 on my calculator. So that's going to be almost a 3 like that. All right, so now I'm bringing that back up here. So once again, if you need to check those on your calculator, just pause the video, do those on your calculator, see if you get the same values. Now, once again, we can kind of see the shape here, right? So I can definitely see it's going to come up, go through, and notice it's got to come up and keep following that vertical asymptote in this direction. And then the same thing here, it's going to turn and kind of keep going down in that direction. And we know it's not going to turn and come back up because there's no x-intercepts, right? So it can't come down here at this point and come up and follow, right? There's no x-intercept in that direction. All right, let's sketch a couple more points out here. Let's go to 5 and 6. So this would be -1.45. All right, when I plug that in my calculator, so 5 is -1.45. So like almost -1.5 right there. Okay, and then when I plug in 6 into my calculator, I get -2.28. All right, and so -2.28 is a little bit more than 2 here like that. Now, once again, when we kind of look what's happening, it's going through these points. It hits this point, all right, and it's going to just keep going, go right up that vertical asymptote, and then once again, we kind of get a little bit of a bend here, and it's going to kind of keep going in that direction. Once again, no horizontal asymptote. All right. So notice these are definitely longer type problems, right? These take 10 to 15 minutes per problem, all right, to go through and do them. All right, so we're going to take a couple of days to go through these, all right, but the process is the same for each one. Now, the other thing I want to emphasize here is that these are sketches. These aren't like specific. So like your curve might bend a little bit more than mine, right, or whatever, but as long as you have enough points, all right, we definitely have to have all these other key things, right? So if you have your vertical asymptotes and those things, right, it's really what we're judging, all right, and then a few key points to finish off your graph. All right, so thank you for staying with me. I know this was a little bit longer than normal, just that's the type of problem that we're dealing with. We're going to do a little bit more in class, all right, on this. I'll see you next time.